Hey everyone, today we're going to be looking at formulas and relationships. Now, what I want you to think about real quickly, and feel free to pause the video here, is what are some formulas you might already know? A lot of the formulas you might already know are going to do with measurement, right? So take a moment and just think about some formulas you might know already. Now, for me, some of those formulas that come to mind are things like with your rectangles, okay, that our area is equal to length times width, and that our perimeter of that is equal to 2 times the lengths and 2 times the width, right? So that's a really simple one we might know. Another one being your triangle, having that perpendicular height and your base, and knowing that your area is equal to half times that base times that height, okay? Some other ones you might know are things like E equals mc squared, if you're a bit of a physics buff, or things like your area and circumference of a circle, where you've got that radius, having your area be equal to pi times the radius squared, or having your perimeter, or your circumference, sorry, I should say, being equal to 2 times pi times the radius, right? So there are some formulas that you would have already used before. What we like to do in algebra is apply those formulas, substituting in values or even rearranging them, which we'll get to. Now, all a formula is an equation of some kind that contains 2 or more variables, right? So what you'll notice about those ones that I had before was things like length and width being included in the one equation, base and height being included, radius and perimeter, and area being included. So you've always got 2 or more variables, right? Sometimes you're going to need 4 variables to substitute in, sometimes you're only going to need the 1, okay? Now, one really important thing to note here is that each formula has what we call the subject, okay? So if I brought that back to your area being length times width, well, then your subject is the area, right? But we can, if we want to, make the length or the width our subject instead, which is useful in different circumstances, okay? Now we're going to have a look at actually applying a formula when given values, okay? Now, one formula that you might be familiar with is the area of a trapezium, okay? Trapeziums look like this, all right? Where once again, you've got that perpendicular height, we have a smaller base and then a larger base, okay? And this is the formula we use for that area. Now, let's say we had a trapezium that looks like this, and that we've got a height of 4, a larger base of 9, and a smaller base of 3, okay? Sometimes we're not going to give you the image. You might actually just have to figure out which formula you're going to use, right? In this case, I'm going to take that formula that I had, so half times A plus B times the height, okay? And I'm going to assign each variable just a different color so we can see where all of these are coming from, right? But if I wanted to find the area, I'll be substituting in A and B and then multiplying by the height. Now, our A in this circumstance is 3, our B is 9, and our height, is not H, our height is 4, okay? And then it's just a matter of simplifying that down. Now, in this case, we've got 1/2 times 12 times 4. Half of 12 is 6 times 4 is going to give me 24. And if you don't have any units, we just say units squared. Okay, now feel free to pause and give this one a go by yourself. However, keep in mind you are finding H instead of A, right? Now, in this case, we've been told our area is 36. So where there is A, I'm going to pop that 36 in. Then I've still got my half times A plus B. So A being 6 and B being 4. And we're going to times that by our height. Then you're just following through and solving like normal. Now 6 plus 4 is 10, and half of 10 is 5, multiplied by height. is h. Then we're going to divide both sides by 5. And that's going to give me 36 over 5 is equal to h, remembering to leave our answer as improper. Okay, so with formulas, you should hopefully just be able to sub in the values that you are given. Now, the other thing that we can do is rearrange a formula. Sometimes we want to solve for a variable that's not our original subject, right? So in that area problem, we might be solving for height like we did before. Now we can plug in values and solve. The other thing we can do though is we can rearrange the formula from the beginning. So that way we have the variable that we're solving for, okay? So we call this rearranging because what we're really doing is moving things around, right? And that's our goal is with this to change the subject of that formula. So the formula we're working with here is P equals 2L plus 2W. But my goal here is to make W the subject. So my goal is to eventually get to a point where we have W is equal to something, right? And we want to isolate W like we do with normal equations. Okay, the only difference here is that we're still going to be left with some variables. Now, if I want to isolate a variable, I'm going to follow the exact same steps I always would. Okay, so we're going to try and get as far away from that W as possible. And I'm going to start by subtracting 2L from both sides. So I'm left with, and I might move that 2W over as well. So I'm left with 2W is equal to P minus 2L. Then I'm going to do what I always do and divide 2W by 2. And so what I'm left with is W is equal to P minus 2L all over 2, okay? So when I get to these questions on the right-hand side, I can just sub in values instead, all right? Now, whenever you use a formula, make sure that you rewrite it out so that you know exactly what you're working with. Now we've got that L is equal to 5 and P is equal to 30. So I have 30 minus 2 times 5 over 2. 30 minus 2 times 5 is 20, divided by 2 being 10, okay? Feel free to pause here and have a go by yourself, but I'm just going to do the same thing now. Is I've got my width is equal to P minus 2 times L over 2. That means my width is equal to 32 minus 2 times 6 over 2. 32 minus 12 would once again, pardon me, be 20, and so my width is once again equal to 10. And we're going to say units because we're still finding a unit of measurement here, but we're not sure if it's centimeters or meters, so we just call it units. Okay, but that is how you rearrange a formula.